Welcome all. Welcome to this lecture of Java. Today we'll be looking at objects and classes and some features of Java. Okay, especially we'll be starting with object-oriented programming in Java. Okay, so let us go ahead. Okay, so these are some of the features of Java. Okay, these are some of the features of Java that you should be remembering. Okay, or you should be knowing in order to go ahead or well with Java programming. Okay, so basically, see, Java is a simple, and since why it's simple is because it inherits the C and C++ syntax. So it's very easy to learn for those who have already learned C++. Okay, when it is secure, why? Because it provides a kind of firewall between the network application and your computer. Why? Because whatever Java program that you run, okay, suppose there is a class file, let's say a class, my class is there, and we know that the Java makes class files, right? Where after you compile your Java code, it's converted into a class file. So this class files always execute inside an environment that is Java runtime environment, right? So, or we can say JVM, Java Virtual Machine only. Inside JVM only this class files run, right? So that JVM provides you a secure environment. Okay. So when you basically use a Java compatible web browser, you can safely download the Java programs and run it. Okay, because the Java programs run only in JVM. So your browser also needs to have JVM inside it. Otherwise, your programs don't run directly. Okay. Portable, it is not dependent on any operating system. If you compile it on a Windows system, if you compile a Java code on Windows system, you can run that class file that has been generated from compilation into any other operating system. Only thing is that for that particular operating system, you need to have the Java runtime environment installed in it. Okay. Then it is object oriented. Everything is in the form of an object. It is very robust because it has got good memory management in the form of garbage collection. Runtime errors handling is also there with the help of exception handling. It does the runtime error checking. Okay, and it is multi-threaded. It allows you to write programs that do things simultaneously. So multiple methods can run at the same time. Okay, that is multi-threading. Then it is architecture neutral. Write once, run anywhere, anytime, forever. Right? So even if the operating system upgrades or processor upgrades, it will not affect the code. Okay. It is interpreted in high performance. Normally, interpreted languages are not having that good performance, but still Java is having high performance. Why? Because it has got the bytecode. Bytecode is not fully interpreted code. It has got half of it as a compiled code, right? So what is this bytecode? When you have a .java file, okay, and you compile it, when you basically compile it, it becomes a dot class file. Okay, that is a bytecode. This is the dot class file, which is nothing but the bytecode. So this bytecode is designed such that it would be easy to translate directly into native machine code wherever you run it using a just-in-time compiler. Okay. So how do we run our Java programs? By saying Java and the class name, right? Java and the class name. So when you run this, what happens is this Java command invokes the interpreter and it loads this class, and that class is being interpreted. That class file, that bytecode inside that class file is interpreted, and along with that, to make that interpretation fast, a just-in-time compiler is also used. Okay, so that you get high performance. It is distributed. It supports distributed application programming. In the way it has got RMI inside it, it supports remote method invocation. So it's like there are two machines. Okay, let's suppose that there are two machines. One is a client machine, okay, and there is another server machine, okay, and in between there is what, a network, right? And you have a Java object running over here. You have a Java object running, or maybe let's say a Java application. We can say an application. A Java based application is running on this client machine, and it needs to invoke an object, right? An object. So you see this over here in this client machine, there will be a stub object, okay. The stub object will be there, and there will be, the actual object will be there. The actual object, this is the actual remote object. Why it is called remote object? Because it is present on a machine which is remote to the client machine. Because in order to call that, what we have to do is, see, this Java application calls this stub object, thinking that that object is present over here in the same machine. But that's not the case. Actually, this stub object makes a request to this another stub object, which makes a request, sends a request to this actual remote object. Or you can simply say that through the stub object, the call goes to that remote object. Okay, and then that remote object replies, and that reply is given back. So this application thinks as if it is communicating with a local object only, an object which is present in the local JVM, in this local JVM. But that's not the case. The object is present remotely on some another machine over the network in some another JVM. So this thing is possible, this accessibility is possible with the help of what? The help of the concept called as remote method invocation. And this is usable, this is needed in distributed applications. Okay. So this is one of the concept that Java supports. Okay. That's why it is called as distributed, and it is dynamic. So, the bytecode may be dynamically updated on a running system. That's one of the features. So these are the features of Java. Okay. Now let's understand the object-oriented programming principles. So basically, these two things that you see over here, these two things are the main pillar on which the object-oriented programming is built. What are these two things? That one is the class and another is the object. So class is basically a blueprint or template for making an object, okay? And what is an object? It's the instance of the class. So if you have a class, you can have multiple instances out of it, right? The way we have, let's suppose we have integer data type. So we can have, for this integer data type, we can define multiple variables, A, B, C. All these variables may represent what? All these variables may represent multiple area in memory. Okay, suppose this location. So this, one of the location may be used by A, another by B, another by C. Okay, what are these? These are memory locations, right? So basically, when you want to use a particular data, you need a data type, right? And when you use the data type to define the variables, you are doing what? You are allocating some memory locations for your program. In the similar manner, what happens is there is a class template that defines that you want to use this kind of data. Okay, some specific kind of data you want to maybe use. Okay, And in order to define that data structure, you define the class. Okay, you also now here you what the case is that you also have the data, and you may also have some methods. You may also have some methods to access those data in a class. Okay, what is this? This is a class. So class is nothing but a template or a structure that is defined for that object, that what that object will be having, what properties will that object be having, how that will be described and all. And out of that object class, you can create various objects. Okay, you can create various objects. The way we have data type from which we can create various variables, in the same way we have this class data type and we can create various objects out of it. Okay, so these two are main. These two are main on which the object-oriented programming principles are based. These are the practical aspects of OOP. Okay. Now, once you know the practical aspects, now then you have to understand the theoretical aspects of object-oriented programming, and those are nothing but these four, which are also known as the main pillars of object-oriented principles. Okay, or three. There are actually three pillars: encapsulation, inheritance, and polymorphism. And abstraction is one of the concept. Okay, but we can consider these four on which the actual object-oriented principles develop. Okay, so what are object-oriented principles? Basically, object-oriented principles are those that deal with programming the objects. Okay, and revolve around the behavior and association of objects. Okay, so these principles focus on how the objects are associated, how they behave, how they interact with each other, how we design an object. Okay, all these things are covered under these principles. Okay, so for example, let's say encapsulation. For example, let's say encapsulation. Okay, so encapsulation says that you can encapsulate something into a single unit. Okay, like for example, you have some data types, different data types, a variable of different data types, right? And you want to wrap it into a single unit, right? So normally, what do we use? We use a class. We use a class to encapsulate all the variables into a single class, and then we make a single object out of it. We make a single, or we can even make n number of objects out of it. But that, if you consider that single object, then that single object has got all these properties, right? So it means that this object encapsulates all these properties inside it. And encapsulating is sometimes also called as data hiding. You can even hide these, you can even hide these variables or this data from outside access. Nobody other than this class itself can be able to use it. That is the best example of encapsulation. It does what? It wraps up the data and functions into a single unit. So it's not necessary that these are only data units. This may also be the methods, okay, or some functions. That's it. Okay. So class is a basic example of encapsulation, where you encapsulate what? Where you encapsulate the data and functions into a single unit called as class. Okay. And now consider if we consider second object-oriented principle, that is inheritance. Inheritance is the process which shows that how objects basically acquire the properties of another object, okay, or how a class acquires the properties of another class. So see, inheritance basically deals in this way. Encapsulation means what? See, if you have, let's suppose that there are some variables. Let's consider this red dot. Okay, let's consider this red dots. as what? These are private variables. Let's consider these to be as private variables. Now you have made what? You have made these variables as private. So these are not accessible to the outer world. Okay. So what you may do is you may allow to access them using public methods. Okay, you may allow to access them using what? Access the public methods. The public methods can access this private variables, and public methods can be accessed by the outside objects. Okay, so these are what? These are basically public methods. We can even have what? We can even have private methods like this. But that will be only useful in the class itself. Okay, that would be only useful in the class itself. These are private methods. Okay, so what happens is that if you want to access these private variables, you may need to access public methods, which can in turn access the private variables. So you don't have direct access to the private variables, so that you cannot change it, right? And there can even be public variables. These are what? These are the public variables. Okay, so these public variables can be accessible from outside directly. The way this public methods are accessible, in the same way this public variables may be accessible. So now what has happened is the data that you want to hide from direct access, okay, the data that you want to hide from the direct access, that you have made as what? You have made as private. Okay, and the data that you want to have public access is made public. Okay, understand? And the methods that you don't want to be accessed from outside is private, and the methods that you want to be accessed publicly are outside, the public methods. So this is nothing but a what? A class, which does what? Which encapsulates the private variables and private methods inside it, and allows the use of those private variables through public methods. Okay, so this is an example of what? This is actually the encapsulation. What? You encapsulate or you hide some data in such a way that it cannot be accessed directly, but only through the public entities. Okay, understand? Class is the best example of what? Class is the best example of encapsulation. And similarly, there is inheritance. Inheritance basically does what? So if you have a class, suppose let's say we have a class, okay. Let's call this class as the super class. Okay, this is super. And now we have another class called as sub. Okay. So this subclass inherits from superclass. Okay. And this is the notation of inheritance, that the subclass is inheriting from the superclass. Okay. Now suppose this superclass has got some properties. Let's say the superclass has got some properties. Okay. and the subclass inherits the superclass. So maybe these properties would be in such a way that it can be inherited by this subclass. So these properties also get inherited by the subclass. Okay. Along with that, if the subclass has its own properties, it can have its own properties. So see what happens over here. Here basically the superclass had got three properties which when inherited by the subclass along with its own properties. These are what? The inherited properties. And these are what? The own properties. Owns properties. Its own properties. Okay. These are its own its own properties. Okay, so we have this superclass and subclass notation in inheritance. This process of inheriting the properties from the superclass is known as what? Inheritance. Okay, and this is noted. This diagram is the notation of inheritance actually. Okay, specifically when you are using the rectangle for representing classes, and this arrow is represented as the notation of inheritance. Okay. Fine, so that is inheritance. What happens in inheritance? It's a process by which objects of one class acquire the properties of another class. Okay. And now, let's see, there is one more property of object-oriented programming principles, and that is polymorphism. Okay. So now this polymorphism is nothing but the ability to take more than one form. Okay. It's the ability to have more than one form. Right. So basically, polymorphism means that there are multiple ways in which you can identify something. Okay. So there are two types of polymorphism. Polymorphism in Java. There are two types. One is the object polymorphism, and the second one is the method polymorphism. Okay. Method polymorphism says that you may have multiple methods with the same name. Okay. Multiple methods with same name. That is nothing but the method polymorphism. And if you are talking about object polymorphism, then object polymorphism says that there can be different references to identify different objects, or we can simply say that the superclass reference can point to subclass objects. Okay, the superclass reference can point to the subclass object. That's what the object polymorphism says. Okay, so let me just say this. This is polymorphism. Okay, now let me show what happens when you typically represent method polymorphism. Okay, so see, method polymorphism basically is represented in this way. Suppose you have a class A, and it has got a method, let's say This is a public and void method A, right? So suppose this is a method which has got some code, okay, and there might be a similar kind of method. You see, a different method, but with the same name. We say public void method A. Now we cannot use the same signature twice, so there should be some difference in the signature of this method. So here what we do is, here we typically put some parameters. Okay, just changing the return type or the scope of the method would not be sufficient. You need to change the parameters. So even if we say that it has got a single parameter, then what happens is that this method and this method are called as the overloaded methods. Why overloaded? Because overloading is happening on the same name. Same name represents two different properties, so two different methods, two different functionalities. So the same name is overloaded with two different functionalities. So that's why it is called as overloading, right? So that's why these are called as overloaded methods. Okay. And there can be overloaded constructors also. Okay, so for example, if you make a constructor A, okay, this is one constructor, this is no argument constructor, and there can be another constructor that might accept some parameters. So this is a parameterized constructor. Understand? Now the class would end over here. Okay. Okay, so the class starts from here, ends over here. It has got two overloaded methods and also overloaded constructors.
So,
Yes.
so I didn't get those overloading methods. I mean, both the variable names are different, method A and method A integer. How could we overload?
Okay. See, method names are same. Okay. Just a minute. See, the method names are same. Okay. Method signature are different. What is different? Method signature. So see here the method signature is public void method A. Okay. This is the first method. The second method is saying that the return type is same. Sorry, the return type not. Sorry, this visibility modifier public is same. Return type void is also same. Method name is also same, but the rest of the things, that is the list of parameters, would be different. If you simply make a method like this, for example, if you make a method like this, let's say instead of this public, you say public int method A. So if you say something like this, no, okay, then this is not a valid overloaded method. This will not work. Why? Because simply changing the return type will not let the compiler know which method to call when someone basically gives a method call like this. When someone gives a method call like this, when someone says method A, right? How would compiler know which method to call? How would the compiler know that which method to call when someone gives a method call like this, method A? There is no way for the compiler to understand that either the user wants a method that is returning nothing or that is returning an integer value. So this is not a sufficiently overloaded method. Why? Because that is an ambiguity created in calling the method. Okay. So this is this public int method A. This is an ambiguous declaration. What is this? This is an ambiguous declaration. Ambiguous declaration of this method. Okay, so this is not allowed. But what is allowed is if you have different parameters, even if there is only a single parameter, then also that would work. If you want to have n number of parameters, that's fine. So now if I say that I am now calling method A and passing some value to it, okay, passing some value to it, then obviously this method and this method both are what? Both are separate and uniquely identifiable. So there would be no ambiguity in. So there is what? There is no ambiguity in calling these two methods. There is no ambiguity in calling these two methods. But yes, there is an ambiguity in calling these two methods, method A, method A. Okay, understand? So what difference makes? Difference is made in terms of parameters. Now there can be one more method like this, saying, let's say there can be one more method like this. Public void method A, and it has a single integer, one integer, and another integer object. Okay, sorry, another integer variable. So it takes two parameters instead of one. Okay, and now if you want to call this, you will say what? You will call the method like this, method A, and then you may pass two numbers to it. Let's say 1, 2. You may pass any numbers to it, right? So now these two are also not ambiguous. This method and this method call are also not ambiguous. Do you see any ambiguity in these three? Tell me. Do you see any ambiguity in these three method calls? No, right? So basically what happens is there is no ambiguity in this method call. So these are valid overloaded methods. Okay, just a minute. Okay, tell me. So is the doubt clear? Is the doubt clear regarding this overloading of methods? Yes. You understand what is overloading of methods? Overloading is nothing but providing the same method multiple responsibilities. Means there will be multiple methods declared with same name. And why am I saying multiple responsibilities? Because one may be executed in a simple manner and another may be executed in a different manner. Okay, one of the methods may be executed in some manner, the other may be implemented in some another manner. So those are two different kinds of behaviors. Okay, so that is nothing but the polymorphism. But that was polymorphism in the form of what? That was actually the method polymorphism. That is what? Method polymorphism. And now there is something called as what? There is also something called as object polymorphism. So you learned the concept of inheritance, right? You learned the concept that there is this class, let's say there is this class A, and then there is this class B, and A inherits from B. Okay, A inherits from class B. Okay, sorry, B inherits from A, not A, but A is the superclass, B is the subclass. Okay, so now what you say is that, check this out, you can write the code something like this. When you say A1 equal to new A, tell me, is this code correct? Yes, obviously it would be correct, right? Because if the class is defined in such a manner like this, let's say this is class A, okay, and it has got public constructor A, which prints something, okay, and then it closes, and then okay, let me just print something. Let's write over here. In short, we don't have space, so I'll say write SOP. What is SOP? It's a short form for system.out.println. If I say I print something, what? I print A in this. Okay, in this constructor I print A. Now there is a class B, okay, which extends A. Okay, which extends A. By meaning extends means we are actually inheriting from class A. So now class A has got uh, uh, okay, let me do one thing. Let me put some properties also. Let me put some properties also, so that would be easier for you people to understand. Okay, so we say class A, it has got a property int A, and it has got a public no argument constructor, and in that it simply prints what? System.out.println. It says A. That's it. Okay, and then it completes. And then we have class B, which extends. This extends keyword is used to represent the inheritance. Okay, so when we say class B extends A, it means that B is inheriting from class A. So now what happens is, now B may have its own property like integer B, okay, and it will have its own not its own constructor, where we simply say system.out.println, and this will print, we will print over here B, and then the class ends. Now see what happens is, when you say something like this, A1 equal to new A, is this a valid code? Yes, right? So now you tell me the code that I am writing further are valid or not. Okay, I'll say B1 equal to new B. Is this a valid code? Okay. Is this a valid code? Tell me. Yes. Obviously it is. Yes, right? Now, what is there? What else is there to be needed to be done? We have basically one more way of representing the objects. There is one more way of representing the objects. Okay, so now what we have now, another way over here is this way. We say A2 is equal to new B. Is this thing valid? Tell me. This code will work, this code will work, but will this code work or not? Yes or no? Obviously this will work, because this is basically object polymorphism. This will work. So let me just save this. So this is a valid code, this is a valid code, and this also is a valid code. It means the reference type is of superclass and the object type is of subclass. Okay, that concept is called as polymorphism. But the reverse is not to remember this. You cannot say something like this: B2 is equal to nu A. This is not possible. This is not possible. These three types of code are possible, but this fourth type of code is not possible. Okay, let me just say this again. Okay, so that is object polymorphism. Any doubt in this, please do let me know. Yes, guys, any doubt in this, please do let me know. Any doubt in object polymorphism? Yes, so I can see there are no doubt from anyone, and that's a good thing. That's a good sign. So let me again continue with this part. And this, so that these were the main object oriented. Sometimes, in interview, people ask, what are the three pillars? What are the three pillars of object oriented programming? So these are the three pillars of object oriented programming. That's what sometimes people argue, okay, or may even ask in basically in interviews. Okay, so you make sure that you understand these three concepts very, very well. Okay, and the fourth concept is called as abstraction. Now the abstraction is that, what is abstraction? Many people get confused in this particular thing. Abstraction is basically an act of representing essential features without including background details or explanation. Okay. Abstraction is also a process. Abstraction is sometimes even called as a process. Okay. It's also a process of converting real world objects into software based objects. Okay, it's a process of converting real objects into software objects. Sometimes people even refer to abstraction as this. How? See, for example, if you say that you want to you want to create a, let's say, a car object, right? So some might say that the car may have the name, the manufacturer, the capacity, the number of wheels, color, manufacturing date. These may be some of the things, and some even may make, let's say, a car which is basically running on battery. So it's a battery is there for running. Okay, some might obviously cars do have batteries, but that's for specifically some electrification purposes of the car, but not for running, right? But there might be cars that have battery for running itself, right? So now this car is abstracted in a different manner, and this car is abstracted. So car that runs on fuel, on let's say on petroleum. Okay, not petrol but petroleum. This is all this. It might be gas, or it might be petrol, or it might be diesel, right? So car that runs on the petroleum, and the car that, or we can say car that runs on non-renewable sources and car that runs on renewable sources of energy. Okay, so there can be two different cars, you know. The same car name can be associated with two different car objects. So what happens is this car is abstracted in a different format and this car is abstracted in a different format. Understand? So when I say that I am making a car object, it does not mean that I am making a physical car, but I am representing a physical car into a software format. Okay, understand? Now, uh, uh, so abstraction is nothing but the process when you basically, you know, create the real world objects, you know, identify the real world objects and accordingly you create classes for it. And you decide what properties to keep in that class and how what kind of behavior to keep for that particular for the objects of that class. That whole process is also sometimes referred to as abstraction. Okay, so these are basic principles of object oriented programming, which start with class and objects, which are the main things without which OP is not possible, and the three pillars along with the abstraction concept. Okay, understand? So these are object oriented programming principles. Okay, so that's it for the day. And if you want to see how to define classes for objects, uh, see, we can even define that also. Let me show how we can define classes for objects. So for example, if you are making a class for a person object, okay, for a person object, then you may define some, let's say, age and name. Right, you have defined this person object, sorry, a person class. Now, if you want to basically define its what if you want to make its use of its object? So you may define the code for it like this: person P is equal to new. I'll type over here new person. Okay. So now basically this creates a new object, and now what if how you want to access the properties of this person? How would you access it? Through the dot operator. There is something called as dot operator. So if you want to access it, use a p dot age. Now what if you want to assign some things to it? So you say p dot age is equal to some value. Okay, this is an assignment operation where you assign a literal value to an instance variable. This age and name are basically what? These are the instance variables. What are instance variables? Instance variables are those which are defined for a class and its object. Okay, for making the object of a class. So, and that belong to all the objects. Okay. So this is a P object, right? And now we can define its name also. P dot name is equal to ABC. Okay, now we can even define another person object saying person Q is equal to new person. Okay, and then we can define Q dot age is equal to 17 and Q dot name is equal to XYZ. See this? So in this way, we can create an object and assign some values to its reference variables, sorry, its instance variables. Okay, and create even different objects. So see what happens is in memory, there are two different objects created. Okay, one is this object and another is this object. These are basically the P, which is of type person, and it is an object. Another is Q, which is also of type person, and it's an object, and it has got what? It has got some properties like age 18 and name equal to ABC. Okay. Similarly, over here, it may have age equal to 17 and name equal to XYZ. You see? So these are two different objects. One is pointed by P, another is pointed by Q. Okay. And how do you access it? How do you access the the properties of the object? These are the instance variables. Means each instance. See, this is instance 1. This is instance 1. Okay, and this is an instance 2. So there are two instances right now. When we say new person 2 times, we have created two objects or two instances. Objects are also called as instances. So those variables that belong to the instances individually, those are called as instance variables. Why? Because each object will have its own copy. So see, here the age is 18 and here the age is 17. So these are different copies. Understand? These are not the same copies. These are different copies. And that's why these are called as instance variables. Okay. So that's it for the day. Let's close it. And if you have any doubts, please do ask me. Okay. We can have an interaction. Let me stop the recording.